Welcome everybody. Nice to see you there. We're going to be talking about Graviton today. I have an awesome crew of AWS essays joining the webinar with me today. I have Carson, who has been instrumental in writing the instructions that you will use today. I have Maxwell, who's also been a key member of that workshop. And Marcin is our lead developer for the Graviton workshop. There's another workshop that I'm going to be talking later that you will be able to do on your own if you want later. And Marcin is the main author for that one. So what we are going to be doing today, so I'm going to start with a short presentation about Graviton and a couple key points for the workshop. And then you will have two options, either looking at me going through the different steps of the workshop and explaining what I'll be doing, or using the instructions and doing the workshop on your own. So we will send the link to the workshop instructions. The people who are joining as attendees should have received a hash code to get an AWS account on the AWS event platform. I'm going to fully show that a little bit later, but you will have those two options, either watching or doing. And of course, if you have any question during the workshop, there's the Q&A box, as Rob mentioned. We will be answering that. And for the ones who would like a more interactive support, particularly for the ones doing the workshop on their own, we have set up a Discord channel. And again, Rob will be posting the invitation to that Discord channel that you can join, and Karsten, Maxwell, and Marcin will be able to answer your questions interactively on that channel. Okay, that being said, let's start with that really short presentation. Okay, so hopefully now you're seeing the presentation. So just something real quick. Let me present the portfolio of our Graviton-based instances. So Graviton is the name of the range of processors that AWS has been designing and producing on its own based on the ARM architecture. The latest generation of those processors is the Graviton2 processor, which is based on the ARM Neoverse N1 architecture. It's a 64-core processor running at a 2.5 gigahertz frequency. And we have many AWS instances that are powered by these processors. So we now have our M, C, and R families, which are our general purpose families. So we have the M6G, the C6G, and the R6G based instances. We've added the T4G, which is a burstable instance, so something pretty low cost and giving you the ability to run spiky workloads at the best possible price performance. We have the C6GN, which is a family with a really fast interconnect, more targeted at either network appliances, things like firewalls, or HPC workload. And the latest instances that we have released is the X2GD, which is a high memory instance with up to 1 terabyte of memory. All those instances are available right now. They have variants with internal disks. They have variants without an hypervisor for those of you who need to run their own hypervisor on top of them. And yep, they're there. Talking about the workshop. So the workshop instructions are displayed on the screen right now. I totally understand that you are not able to copy paste the instructions right now. So Rob is going to push that to the chat. The workshop dashboard, you should have received with the hash code the link to the workshop dashboard. That's where you will enter that hash code and be able to get an AWS account for the workshop. And the last link is our Discord support server. Again, Rob will also paste that to the chat. So you should have those 3 links. We will be reposting those links regularly during the workshop so that anyone who have missed them could find it there. And if you have any question, of course, please use the Q&A box and ask the question so that we can support you the best possible way. One last thing that can be interesting for you, we have a GitHub repository, the AWS Getting Started Guide, where there's a lot of instructions for people who are adopting the Graviton-based instances, instructions around how to optimize workload for the Graviton-based instances, how to analyze performance, what are the best possible operating system versions that you can use on top of Graviton-based instances, or what are the library version that we or ARM have spent time optimizing, and or the version that we recommend to use on top of Graviton-based instances, that kind of stuff. We update it on at least a weekly basis, when not a daily basis. So basically, every time we discover something new that could help our customers, we are publishing it here. If you do see anything missing in that guide, please let us know, submit an issue, submit a pull request. It's meant to be super interactive. Okay, so thanks for watching that small presentation. We'll share another part of my screen now. So let's go to the workshop instructions. So let me share that one. So now you should be seeing on the screen the instructions for the workshop. So let me check. Yeah, Rob just posted that again to the chat box, so you can use it to get access to the workshop instructions. And just below that link is the link to the Discord channel. The Discord channel is where Max, Carson, and Marcin will be able to interactively help you if you were to have any issue while running the workshop. So talking about the workshop itself. So now the people who are joining as attendees and have a hash code, you will have the ability to run the workshop on your own. The ones who are here just to watch what's going on, I'll be running the workshop myself. So you can follow that, and I will be commenting on what I'm doing. So the first thing when starting the workshop is to go through that getting started. There's two main sections. One is if you want to do it on your own account. So that's usually something that people rather do outside of AWS account events, sorry. But if you want to do it on your own account, you can definitely do it. There's no instructions on that workshop that should not work on your own account. You can definitely do it. One warning though is if you do it on your own account, all the services that we will be using are not free. They're not part of the AWS free tier. So there will be a cost associated to running that in your own account. So if you don't feel comfortable with that, please do not run those instructions on your own account, and rather use one of the provided accounts for the workshop. Since we are at an AWS event, what I offer you to do is to use the AWS workshop portal. So for all the attendees, that's now the time to use the hash code that you've been provided with. Normally, on top of the hash code, you had a URL which includes the hash code. So you should be able to go to that dashboard.eventengine.run, which will display the window that is on my web browser right now with a place to enter the hash. So let me show you that live. If I click here and go to that dashboard, that's where I do see now if you were provided with the full URL, the hash code should be already populated, and you just have to click the connect button at the bottom right. If you have the hash code, and that's what I'll be doing right now. So let me copy that and paste my hash code. Here I am. Let me check. No, I'm using the wrong one. Sorry. Give me 2 seconds to collect the real one. Okay, so here I have my hash code on the window, and I will be able to go to that event engine dashboard. So you can sign in either with your Amazon account or a one-time password, or for myself, I will be connecting as an Amazon employee. So let's do that. And here that's the dashboard for the event. And now you have the ability to set your team name. So here I'm going to push my name. And then you have one link that allows you to open the AWS console. And that's where we will be doing all the work today. So the workshop is going to run in US West 2, which is one of our region. So here I'm going to click open the AWS console. And now, oh, sorry. I was probably connected to one of my own AWS account. So I will connect again. And here I am connected to the AWS account through the event platform that we have provided you with. So I'm going to probably make a little pause here, check the chat box and the Q&A box. If anyone is having trouble with the hash code, or if there is something that you have not understood in the various steps that I've shown so far, please just let us know, connect to the Discord channel, or ask question in the Q&A box, and Max, Karsten, or Marcin will answer. Okay, so let's go back to the workshop instructions. So now that we are connected to the workshop platform, and that we have an AWS account that is ready to execute the workshop, the next thing that we will do is to set up a Cloud9 environment. So Cloud9 is a development platform that you can use on AWS. It allows you to do development, but also gain access to a console on an AWS instance. So it's a pretty convenient platform to interact with the AWS platform and to run workshop. So that's what we are going to do today. So I'm going to go back to the AWS account and click Cloud9. So you can also access that at the top by accessing the full list of the services. So here I'm going to select Cloud9. And it brings me to the console of the Cloud9 service. So I'll create an environment for today. So I'll call that Graviton2 workshop. And click to next step. If I look at the instructions are telling me to create that Cloud9 environment, to select a m5.xlarge instance, to limit it to 4 hours, and then to create the environment. So that's what I'm going to do. I select over instances, M5, xlarge. I'll move that to 4 hours, leave the role as it is and click to next step. And now the environment is going to be created. So it takes a little while to provision the environment because it means launching a virtual machine on AWS. So while we are waiting for that to happen, we will go to the next step in the workshop, which is to create a role for the Cloud9 environment. What we will do here is that we will create an IAM role for AWS. So that's a role that will give permissions to the Cloud9 instance that we will be using today. So the link we will click here will bring us directly to the console and allow us to create a role for an AWS service. So we will attach the administrator access to that role so that the Cloud9 instance will get full permissions on this AWS account. Click next. We don't need to add any tag. Oh, my mouse has disappeared. Okay, found it back. Click next, and we will add a role name. So if I remember well, we are supposed to call it Cloud9 admin role. So let's copy that, and here we are. Put the role name here, and we'll leave it like that. And now let's create the role. Okay, so we have our role. The next step, once it is created, is to go to the EC2 console. And through the EC2 console, we will associate that role to our Cloud9 instance. And then later, we will go to the Cloud9 instance and use it for the rest of the workshop. So let's go to the EC2 console. On the list of the running instance, which is pretty easy here, there's only one, we have our Cloud9 instance. Later during the workshop, if you were to reconnect to that window, you would see more as we will be launching several other instances. We will go to the action security, modify the AIM role for that instance. And here we will use the Cloud9 admin role that we have just created. So still remember what we are doing here is associating a role to that Cloud9 instance so that it would get all the privileges needed to interact with the AWS services and be able to do the next step in that workshop. So let's select it and apply it. Applying a role to an EC2 instance is immediate. So all of a sudden, as soon as you have applied it, the instance will get all the privileges that are granted by that role. So now we have the AIM role that is applied to the Cloud9 instance. So if we go back to the instructions are now telling us to go to Cloud9 preferences and change a little parameter. So I'm going to go to Cloud9. I'm going to accept what it's telling me, which is not really important. Let's maximize the terminal window. And the first thing that I'm asked to do is to go to the settings. So that's the little white wheel at the top right corner, and go to AWS settings and disable the AWS managed temporary credentials, because we are getting the credentials from the role that we have just created. So let's remove those various things and declutter the screen. Okay, so let's go to the next step in the instructions. So what we have done so far is we have created a Cloud9 instance, which has the right level of privileges to be able to interact with all the AWS services in our account. And we will use that for the rest of the workshop. So now we'll go to the next step, which is to install all the prerequisites, the various software and settings that we will need to run during the performance lab. So the first thing I will do is to clone the source code for that workshop. So we have a GitHub repository that contains all the source code for that workshop. Actually, it contains a little bit more because it also contains the instructions for all our Graviton lab. And today we will focus on one sub part of that one that can fit into a 1-hour workshop. And I'll go to the Cloud9 environment and paste that to the window. So it has cloned the repository, and I'm now in the folder where we have all the code from that repository. We can see that on the screen right now. Let me check if I can make that a little bit bigger. I'm not sure that you guys can see that on your screen. Does not seems to work. Okay, I'm sorry, not sure how I can make that bigger. I hope that you are able to see that on the screen share. Okay, so now we have cloned the repository. The next thing we will do is that we will update the AWS install and upgrade the AWS CLI, which is something we always recommend to do when installing a new AWS instance. Ensure that you have the last version of that tool, because that's what will give you access to the latest services on AWS. The next step is to install a couple tools that we will use during the workshop. GQ is a tool that allows you to parse and print some of the answers given by the AWS CLI, and there are various tools that we use during this workshop. So let's install those dependencies. There's a couple packages that needs to be downloaded now. Okay, that's done. Next step. There's a couple environment variables that we will set up during the workshop to make it easier to run. The region is one, the account ID is another one. So here you have a couple requests that are made just to get those variables, store them in the configuration of the Cloud9 instance, and export some of them so that they will be, so that it would be possible to reuse them later. So let's copy that part and let's push that to our instance. Okay, so we should be good now. Well, the link role, there's an error about the link role, but we will not be using that one during that workshop, so that should be okay. Next thing is we will create a SSH key that we will use during the next step to connect to the instances that we will create. So let's create that SSH key. I'll type answer 3 times to save it without a password so that I won't have to type that password in each time I will be using that SSH key. And the next step is I will import that key that I just created as an AWS key. And the role of that key is that it will be added to the authorized list of the instances that we will create later in the workshop. And that's what will allow you to connect to those instances using SSH. So we will register that key. Okay, here we are. So now Graviton2 key is part of the list of keys of my AWS account. And when I will launch an AWS instance on the AWS platform, I can tell it to use that key to authorize my login. So the next step is we need a little bit more disk space on the Cloud9 instance. By default, it gets 10 gigabyte, which is totally fine if you just want to do Lambda development or things like that. But for the workshop, we need a little bit more than that. So we have written a script that would make the EBS volume, that is the disk of that instance, a little bit larger, and then we will install a couple more dependencies. Among those dependencies, there's a tool called AWS CDK, which is a high-level construct, a open source framework that you can use to define infrastructure as code. You can do that using several languages. TypeScript is the default for that tool, but you can also use Python and a couple of others. So let's install all those stuff. Let's go back to the terminal and launch the resize. So while it's installing everything, I'm going to have a look at the chat and see if there's any question anywhere. So I don't see any question in the Q&A box, nor in the chat box. So it seems like you are doing good. A couple of people have joined the Discord channel. Welcome. If you have any question, don't hesitate to put them there. So on the screen right now, what you are seeing is all the CDK dependencies being installed. It's going to last for a couple more seconds, a little bit less than a minute. And then we'll go to the core of that workshop once we will have all those dependencies installed. So it's now bootstrapping the CDK setup. CDK is really an interesting alternative for those of you who might have already been using CloudFormation. It's definitely a higher level construct. CloudFormation is mainly a declarative language in which you can describe your infrastructure as code. CDK is way more powerful than that. You can predefine pieces of your environment as functions. You can derive those classes and functions into new constructs and reuse them several times. It's really modular. Okay, so let it complete. We're almost there. While we are finishing, I'm going to try to reconnect my Wi-Fi mouse that I lost during the workshop, the beginning of the workshop. Things always fall out of battery in the middle of a workshop. That's normal and expected. Okay, we are almost there. And the last stage for CDK. And here we are. Okay, so now we have all the dependencies that we need for the workshop fully installed, and we can go to the next step. What we will be doing today is have a look at the various methodology that you can use to do some performance engineering on top of Graviton-based instances. That's a challenge that we do see many of our customers adopting Graviton having, which is they are moving from an existing infrastructure, usually based on x86 processors, and they start to adopt Graviton. And they have some trouble evaluating the performance impact of moving from one to another. So what we wanted to target in this workshop is to give you a couple of tools and a couple of methodology on how you can evaluate the performance of a web application and study the impact of changes on that web application. And those changes can be many. That can be the changes of server/processor type. That can be a change of operating system or underlying library or a runtime, and have a repeatable process where you can check what happens with the previous configuration, check what happens with the next one, and compare the result of the change, and do that in a really repeatable manner. So let's switch to the beginning of that. So what we will do here is that we will do another round of pre-setup for that workshop. So the first thing is we will export as a environment variable an IP address range that we will use to deploy some test systems. So let's do it. The next thing we will do is export the name of the key that we have created during the first prerequisite step. So we had named that key Graviton2 key, and we will reuse that name here. For the ones that are doing the workshop on their own, please pay attention to really reuse the same name as what you have created before. If you choose a different one, it won't work unless you really know what you are doing and you have created a second key. But yeah, I really recommend to stick to the previous one. So let's do that. Next thing is we will collect the name of the availability zone in which we are running. Again, that's going to be useful to deploy the systems that we will test during the workshop. So let's do that. And we will also export the name of our CloudFormation stack. So we haven't yet ported that lab to CDK, and we will still be using CloudFormation. So CloudFormation, as I mentioned earlier, is a declarative language that allows you to define an infrastructure. And here what we will do is deploy such a predefined infrastructure that will be composed of three instances. We will use a client instance, an M5 X large, that we will use to as a test client that's going to be the load generator for our performance experiments. And we will deploy two system under tests that will be running on Graviton2-based instances. And from the client, we'll be running a couple of tests, again, those two instances, and study the differences when we will change a couple of components. So let's start by deploying that stack. So I've copied that, and let me paste that to the Cloud9 instance. So you remember that we have created an AIM role earlier in the workshop, and that I said that the goal of that AIM role was to give the instance the privileges that were needed to interact with the AWS services. And that's exactly what we are reusing right now. The CloudFormation stack that we are using, and I will show you that stack just a little bit later, is actually creating stuff on your behalf on the AWS account. So you need to have the privileges to launch EC2 instance, create the network constructs like security groups that allow instances to communicate with each other, and all the privileges that we granted previously allows it to do exactly that. So the stack takes a while to provision, of course, because it requires a couple of instances to be created. What we can do while it's doing it is go to the AWS console and go to the CloudFormation service. So what we have been doing through the command line could also be done using the console, so the web graphical console. And the stack that we are creating right now in the Cloud9 instance, so you can see that the AWS CloudFormation deploy, where we put as a parameter the stack name, that same exact stack name, Graviton2-Lab, we can see here on the CloudFormation console. So the Graviton2-Lab stack is now creating progress. And what we can do is go to that specific stack and have a look at the events that are happening right now. And we can see that that we have initialized the creation of that stack. There's a service role that is being created. There are a couple network constructs and services that are being created, an instance profile. And if we have a look here, those events will keep on being updated, and we should soon see instances being created. So here we have a couple instances that are being launched and initialized, security group created. And in a little while, we will have those instances available and we will be able to connect to them. If I go back to the CloudWatch instance, and if I go to the Graviton workshop, so here in the scripts folder, you will be able to find that CloudFormation template, which is called cfntemplate.yaml. And here is the real code that describes that infrastructure that we are deploying right now. So it has a couple of parameters we can, so that a couple of options, let's say, so that you could change them when you are deploying it. And then it describes all the infrastructure that we will be creating. So the instance profile, the placement groups, the instance types, the various pre-initialization scripts that we are running on those instances, all those stuff. That's really convenient because you can reuse that infrastructure, and just by calling the deployment of that stack, you will have a super repeatable infrastructure being deployed where you can do your performance tests. So let's have a quick look at where our stack deployment is. So our stack is deployed. If we go back to the CloudFormation console, we can see that the creation has completed. And if we look at the list of resources that stack has created, we have a couple EC2 instances, so a client, 2 systems under test, and a few other constructs that are mainly meant at allowing those instances to talk to each other on the network. Okay, so where are we now? We have a Cloud9 environment where we can type about all our commands. And we have deployed an infrastructure that is composed of one client and two systems under test. So the next thing we will do is we will do a couple API calls to the CloudFormation stack to collect the IP address of the three systems that we will be interacting with. That's going to be more convenient. We will export in our environment the IP addresses of those three systems. So that's what I'm going to do now. Okay, so now I have in my environment those three IP addresses, and I can test just to be sure that everything worked well. I'm going to try to connect to the client system. So it asks me to validate the SSH key. Sorry. Oops. I lost the connection in any way? Okay, so my keyboard is no longer reactive. Let's try to refresh my window. Oh, now it seems to be back. I'm not totally sure. Okay, what was happening here? Okay, it seems like I'm on the test client. Let me. There's been a glitch. Yes, we are. Okay, so the test client is there. There's just been an issue with my keyboard and between my keyboard and Cloud9, but we are all okay. That was super weird. So let's disconnect from the client and go back to our Cloud9 environment. So I've unlocked from the client. And so far, we have our infrastructure with one client, two systems under tests. We know that the communication is okay between the Cloud9 event and the client for the workshop. So we are good to go to the next step. So let's talk a little bit about the use case that we will have today. So what we have done is we have deployed within a VPC, so the network construct for an AWS infrastructure. And here we have deployed, well, not two clients like displayed on this image, but actually just one, we don't need more, and two systems under tests. And those various systems are in security groups. So let's think about them as firewall constructs that you can use to allow communication between groups of instances. And all those systems will interact together during that workshop. So the second thing that we have done is that we have developed a small Java-based application. Well, actually, Karsten and Max have developed that application. They're the brain behind that workshop. I'm just a guy talking a lot. And that application is going to expose an API and a REST API on the network. What we will do now is we will, so if you take a step back and look at what performance measurement and analysis all mean. So usually what's going to happen when you're an infrastructure engineer or that you have to deploy resources on AWS, the application owner is going to tell you, yeah, that's cool. You want to adopt Graviton-based instances, but what's going to be the impact on my application? And actually, that could be way broader than just about Graviton-based instances. That could be just, well, what's the impact of any change on my application? And you will have that task to measure those impact and justify why any change is good or bad. And that's exactly what we will do with that lab. So you could run that lab actually with application in many different languages. Here we will study a Java-based example, but we plan to develop more example with various other languages in the future. Here we've been using the Vertex framework, which is a framework that allows to easily develop web application. But the methodology is actually applicable to any language that you would be using. So now let's have a look to really how we can install that application and measure what it is doing. So the first thing we will be doing is connect to the first system in your task. So I'm gonna go a level up and connect to that system. Okay, good thing this time my keyboard is not sending 1000 yes. So the connection process is going to be smoother. So now we are connected to the first system under test. If you look at the architecture, well, it's indeed running on an ARM64-based instance. You can see that the kernel version is contains ARch64, so it means that the underlying processor is a Graviton processor. Actually, if we were to do a cat/proc/CPU info, oh, wow, that's indeed a Graviton processor. So next step, we will again clone the repository for the workshop. You will see me do that a couple of times today. So, okay, we have the sources for the workshop, and the sources for the application is inside that Git repository. And all the scripts that we will be using are in that Git repository. So if you want to reuse them for your own use cases, you can definitely take them. They are open source. Just take them. And if you have any question, send us an email. I'll be providing you with an email address that you can use at the end of the workshop if you have any questions or comments about those various tools. So the first thing we will do is to use Maven, which is a build tool to build the application. So we have the pom.java8.xml file, which contains all the instruction to build that application. It has a lot of dependencies, so that's the reason why you are seeing on the screen many packages being deployed. And what we are doing is create a big archive that will contain all those dependencies and the application code. So now if we have a look to the target folder, here we have a webbook bookshop-fat-jar that contains the entire application. The next thing we will do is to launch that application in the background. So obviously in production, you would have most probably a more complex setup. There would be a real daemon and not the hack that I'm using here. But for a workshop, that's going to be way sufficient. So now we have that Java process that is launched with our application. So let's go back to the instructions, and we will try to reach out to this application and check whether the API is working as expected. So we get the answer from the application. You can see lots of good books. That's a library application storing all those things in memory. And we will now be able to study its behavior under load. So the application is ready. Now we will disconnect from that system, do exactly the same on the next system under test, and then we will apply some load on the system and measure the response. So let's do that for the second system. So I'm going to log out and then use that command to log to the second system. Here I am. And here I will redo the previous steps. So let's start by cloning the repository. Oh, I forgot to change the IP address. Actually, okay, so system under test 2. Oh, I mixed up and I've done the system under test 2 first. So let me now install everything on the second one. Okay, well, I have it in both. Not sure what happened, but that's good. So the application is running on both, so we are good. So now what we will be doing is connect to the client and set up everything so that we will be able to apply some load on the client. Okay, so here we are on the client. And we will export the region and pre-configure the AWS CLI. We will get the IP addresses from the two systems under test. And now what we will do, and that deserves a couple of explanations, we will use a tool called WRK2 to apply some load on the web application that we have deployed. So WRK2 is a pretty convenient tool because it allows you to define many parameters, including the number of threads that you will be using, the number of connections that you would be using. And more than that, it allows you to stand a steady flow of requests on a particular system that you want to test. So here, for example, we will send a workload where we will use 2 threads to keep 100 connections opened all the time during 30 seconds, and we will send 2,000 requests per second. So that's a really predictable workload. It's going to be pretty stable. We can reuse that as often as we need, and we can change the number of requests per second to stress the application at various levels of load. And you can use that to determine what is the maximum that your application can handle. You can increment that level until the point where the latency will start to peak. So it's a really convenient tool. And the interesting aspect is that it's going to measure the time that the application takes to answer and show you the various latency percentiles while you are doing it. So let's run it. So it has been running for 30 seconds. And the really interesting thing about this tool is that it shows you the latency percentile for your application. So you can see that more than 50% of the requests were completed under 1 millisecond. And if you look at the longest requests, you can see that the last 99.99% of the requests were taking more than 9 milliseconds to run. So that's a pretty interesting information. It gives you how long your application takes to answer the request in general, but it also shows you the outliers for that specific parameters. We could do exactly the same thing with the second system. It would report more or less the same information, so we will skip that for now. So far, we have installed that Java application on the 2 system, checked that everything was working, applied a first level of load, and learned how to measure those performance metrics. So now, let's have a slightly deeper look at how we can go further with that. So there's 2 interesting metrics that we are using in these benchmarks. One is the number of requests per second that we apply on the system under test. The other is the response latency that we measure. And those are definitely key. And what is super convenient with WRK is that it measures for you the latency percentile while the system under test is answering the workload. So the second thing that we will do here is that we will use a slightly more complex version of the previous script to run a more significant workload. So we will be using a wrapper script that we have defined, which will generate some data and allow us to graph the data of that specific load. So let's do it. So I'm still connected to the system under test, so that's pretty easy. I can run that directly. Oops, sorry, which one I am on? Oh, I need to install a couple of stuff first. So let's install the repository and then export the system's IP address. And now we can run that more complex version of the WRK test. So this time we will be running at 2000 RPS for 5 minutes so that we will be able to collect enough information to show a meaningful graph. So let's do it. So it's going to run for 5 minutes. So while it's doing it, let me show you what you will receive as when running such a test. So what the workshop will guide you into doing is run that test and then graph the latency distribution of one of those API calls. So that graph, which is pretty similar to the one that you would get, was run on a similar web application. And what we can see is the latency percentile at different RPS rates. And so we have a really clear view of what's happening with our application when we apply different level of loads. So if you're, for example, switching from one architecture to another and see how it reacts under a low level of load, you would be applying a moderate number of RPS for your application, and it really depends on your application. Could be 100 RPS, could be 2000. That's really application dependent, and you will be able to look at the latency and do the same with a higher level of RPS and go closer to the maximum throughput of your application and see how it behaves. And that's a really interesting tool to compare the behavior of systems depending on the load level and see not only the average response time, but also what happens for the high percentile, because those things are really key. It's really to understand what are the worst cases that your user would be doing. Back to the wrapper script that I was using on the client, the thing that we've done with that wrapper script is that we've defined it so that it would hit the various part of the API that we have defined. So it's not only calling one of the entry point, but all of them to stress all the different part of the application. And you can use WRK2 that way so that it would stress all the parts of your application. So the test is still running. We might be a little bit short to have the full results on time for that test. So the graph we would be generated would really look like that one. And that's the key thing that you can be learned in this workshop, is how to interpret that one and see the impact of the latency on your application. The next thing that we will have limited time to do, we'll see how that one is doing. The next step would be to perform a runtime upgrade. So to do that, we would connect on the second system under test and change the Java version and upgrade to Java 11. We know that on Graviton, Java 11 tends to be significantly faster in some cases than Java 8. So by upgrading to Java 11 for that application, we want to check what the differences are. So here we could follow the instructions to rebuild the application with Java 11 and run that with Java 11. And then from the client system, run exactly the same test as the one we are running right now with the first one. So let's check where is it? Okay, so it's still running. We should have the time by the end of the workshop to have a look at the results for the first one. In the workshop scripts, we provide a script that allows to plot those results and to plot the comparison between what we have done on the first system and what we have done on the second system. So you could see the latency curves for the first system and the second one, and thus see the impact of upgrading from Java 8 to Java 11 from that system. The goal of that was to learn the differences, the impact of a GVM upgrade, and that could be applicable to any library upgrade or operating system upgrade. You would apply exactly the same methodology, actually. There are a couple other things that you could do to troubleshoot and optimize an application. One is to use AWS CloudWatch to collect all the metrics from the system on which you are running. So here you have instructions that you could follow to set up a dashboard, and the dashboard would look roughly like that. So you would be able to see the CPU utilization on your system, the memory pressure, the disk's throughput, the network throughput, and when running a specific workload, study the influence of that workload on those metrics. The system that we have set up for that lab have all the tools to report those information to CloudWatch, so it's pretty convenient. One last thing that you could do is to use those very predictable workloads to evaluate the impact in terms of price performance. So the price performance ratio is really the performance gain divided by the cost saving. So to compute that for a test environment, you would 100% as the basis for the experiment. So considering that the price of the overall environment has not changed, and then use the performance increase or decrease as the denominator. And that way, using the formula that we are exposing here, you could compute the price performance increase or decrease for that new environment. I'm going to go back to see whether the benchmark is finished. So yes, it is. So we'll go to the last few steps. We have 3 minutes left. So I'm going to try to complete that one and show you the graph. So here we are. We have just done that workload. And what we will do now is generate a graph from that one. Okay, so the graph is generated. So I'm going to disconnect from that one and copy the output.jpg file from the system under test so that we could visualize it. So Cloud9 has a pretty convenient feature, which is the ability to show graphical files, well, any files actually. So we will double click the output.jpg that we have generated. And here we can see the graph of the latency of our request. So we can see that at 2000 RPS, we have a pretty stable latency and only really close to the 100 percentile latency. We have a few outliers and we have a few API calls that are taking longer. So we have an application that is pretty predictable, always showing the same latency. We have run a pretty short test, only 300 seconds. So potentially we have not collected enough samples to have a really accurate view at what would happen in production. If I were to study a system that I would run in production, I would probably run that test for a little bit longer, like 10 to 20 minutes. And the percentile that we would collect would be more accurate. If we had more time, we would have compared that curve with the one with GDK 11 to see the difference between the two runtime. It's unfortunately a little bit short. If you want to complete the workload on your own on an AWS account, what we can offer is, I'm going to paste to the chat an email address where you can send us an email, ask any question, and request a couple AWS credits to cover the cost of the workshop. So I'm going to paste that address right now. Let's put it to the chat and send that to everyone. So if you want to get credits to do the workshop on your own, feel free to send an email to that address and I will answer you with a credit code. If you want to also do and explore more labs with Graviton-based instances, we have a Graviton workshop with labs that are covering containers, databases, and various other of our managed services. Same thing, if you want to do those on your own account and want to get some credit, AWS credits to cover the costs, I've pasted the link to the instructions in the chat. Same thing, just send us an email and we will do that. Okay, I will stop the screen sharing. We're a little bit over time. Thanks a lot for attending that workshop. I hope that you enjoyed. If you have any question, please let us know. Marcin, Carson, Max, thanks a lot for helping me. ARM folks, Rob, thanks a lot also. And have a nice day, folks.